Okay. In our previous discussions, so we stopped after solving the 10 problems. So today we just continue the rest of the problems on the different chapters. Now look at the slide for the 11th problem. So what is there? A car traveling at 108 km per hour is uniformly retarded. Retarded means its acceleration goes on decreases. I mean its velocity goes on decreases. So decrease of the velocity gives the acceleration, because decreasing means it is a negative acceleration, therefore it is retardation, and brought to rest in 7.5 seconds. So it will be rested after 7.5 seconds. Find its acceleration and distance before coming to rest. Now collect the data. What is given? A car is traveling at 108 km per hour. So because it coming to rest after 7.5 seconds, you have to take this data as a initial velocity. That is, initial velocity u is equal to 108 km per hour. So it has been retarded and brought to rest means its final velocity is 0. From this magnitude of velocity to this magnitude taken place by consuming a time of about 7.5 seconds. Therefore, given t is equal to 7.5 seconds. Then what it is required to find is, find acceleration attained by the body, because its velocity has been changes. So if a body moves with a variable velocity, definitely it has got an acceleration. So if these things happens, so what distance it will be traveled under these circumstances? Its velocity decreases from this extent to this extent in this time. So in this time, how much the distance is traveled by the body? That is the question. So first you have to check whether the given data is in SI unit or not. So seconds is there, 0 is there, no problem. It is 108 km per hour. Since it is a velocity, you have to convert it in terms of the meter per second by following the previous convention what we discussed so far. It is 108 kilo means 1000, that is 10 power 3. Per hour means 60 minutes, 1 minute means 60 seconds. Now it will be in the form of, so meter per second. Now you can rewrite this one as 108 into 10 power 3 divided by 6 into 10. Again 60 can be rewrite as 6 into 10. This 10 gets cancels with 10 power 3. So 6 ones are 6, 6 eights are 48, 6 ones are 6 threes are. This is 3 into 10, which is equal to 30 meter per second is the initial velocity. Then so what we want is A, acceleration attained by the body. The basic formula to calculate the acceleration is change in velocity divided by time taken. So final velocity is 0 minus it is 30 divided by time consumed is 7.5 seconds. So the answer will be negative, because acceleration obtained by the body, because of its decreasing in its velocity, so it means it is a negative acceleration, that is a retardation. It is minus 30 is there in the numerator. 7.5 you can write it as 75 into 10 power minus 1 by shifting the decimal place in the right hand side by 1 place. So you have to multiply it by 10 power minus 1. So now, so 5 1 15 2s are 30, 15 5s are 75. So this 10 power minus 1, when it goes to the numerator, it becomes 10 power plus 1. So it becomes 10 power plus 1, then 2 is divided by 5, 0.54. So again it will be, so 4 meter per minus 4, of course, minus 4 meter per second square is the acceleration attained by a body. Initially it will be moves with 108 km per hour. Finally it is retarded and brought to rest in a span of 7.5 seconds. So under this circumstance, acceleration attained by it is minus 4 meter per second square. Negative acceleration it is, that is why you can call it as a retardation. Then under this circumstance, what is the distance travelled by a body? So here we are required to find the S. To get S, we have many relations in case of the equations of motion. So with respect to given data, U is given, T is given, V is given, we know A. S is equal to UT plus half AT square is the suitable formula to calculate the distance travelled by the body. Again S is equal to U into T. U it is how much? 30 meter per second into T it is 7.5 seconds plus 1 by 2 into A it is minus 4 meter per second square. So T it is again 7.5 whole square. By using any calculating device, you can calculate. Some numerical has been obtained, thus that will be that extent of distance will be travelled by this body. So under the given circumstance, this is about the given problem. So you just concentrate to calculate how to find the velocity, how to find the distance travelled by the body. So move on to the next problem. So the problem is, what force is required to change the velocity of a body whose mass is 2 kg from 20 meter per second to 80 meter per second in 1 minute? I mean here, what force is required for what purpose? So on a body what force is required on a body whose mass is 2 kg. So first try to collect the data correctly. Whose mass is 2 kg from 20 meter per second to 80 meter per second. So initially it moves with a 20 meter per second. So then its final velocity is 80 meter per second. The time is given in 1 minute. T is equal to 1 minute. So it should be expressed in terms of a second. Therefore T is equal to 60 seconds. First try to understand the problem. What force is required to change the velocity of a body whose mass is 2 kg from 20 meter per second to 80 meter per second in 1 minute? I mean there is a body whose mass is 2 kg which is under motion. When it is under motion, initially it has got a velocity of 20 meter per second. By applying what extent of force on this body for a span of 1 minute to change its velocity to 80 meter per second is required to find. I repeat, what amount of force applied on a body of mass 2 kg which is moves with a 20 meter per second to change its velocity from this extent to 80 meter per second in 1 minute. So this is the given data. F is required, m is given, initial velocity is given, final velocity is also given, time is also given. So to have F, you recall the second law stated by the Newton. So Newton's second law, it is force can be defined as the product of mass and its acceleration. Here mass is given but acceleration is not given. Since we know u, v and t, you can calculate the acceleration also. That is F is equal to m into A is v minus u divided by t. So how much is F? F is required to find. F it is equal to m is 2 kg, v is 80, u is 20, time is 60 seconds. So F is equal to 20 into 80 minus 20, it is 60 by 60. These two gets cancels. F is equal to 20 Newton. F is equal to 20 Newton is the it is 2 kg, sorry, it will be 2 only. So 2 Newton is the force required. So the conclusion is, by applying a force of 2 Newton on a body whose mass is 2 kg, which is moving with a velocity of 20 meter per second for 1 minute to change its velocity to 80 meter per second. 2 Newton is the required force acting on a body. Now let us move on to the next problem. Now read out the next problem also. What is given, you have to collect it by scanning the problem exactly. What is given? There is a mass of 100 kg at rest. So mass of a body is given, which is 100 kg. At rest means its initial velocity is 0. Is acted by a force of 720 Newton for 3 seconds. It is acted by a force. How much it is? 720 Newton for a span of about 3 seconds. Then what is its velocity after this time? What is its velocity means it requires final velocity is how much. Then and what is the distance covered under this circumstance. So what is the velocity after this time and what is the distance covered by it once again. So you have to understand the problem clearly. There is a body whose mass is 100 kg initially, which is at rest. So a force of 720 Newton acts on it for a 3 seconds, definitely its velocity has been changes. Now what is the change in velocity under this circumstance? So if its velocity changes from 0 meter per second to something in 3 seconds, under this circumstance how much is the distance travelled by the body is the question. Once again here you are required to find the velocity, final velocity. Which formula we are making to use is, so F is equal to ma is so useful, I think. F is equal to m into a is not given, but F is given, that is the advantage here. F is equal to m into a means v minus u divided by t. That is how much is the F? It is 720 Newton, which is equal to how much is the mass? It is 100 into v is required to find, u is 0, t is how much? T is 3 seconds. Right. So t is 3 seconds, m is 100 kg, v is required to find. So initial velocity is 0, required or applied force on it for 3 seconds is 720. So you just cross multiply it, 720 into 3, which is equal to v minus 0 is v, v into 100 it is 100 v. So therefore v is equal to 720 into 3 divided by 100. So these two gets cancels, 2 5s are 2 3s are 2 6s. So v is equal to 108 by 5. So v is equal to 21.6 meter per second is the velocity of a body whose mass is 100 kg when a force of 720 Newton acts on it for a span of 3 seconds. So then remaining part of the problem is, under this circumstance what is the distance travelled by the body? S is how much? Once again I think it is suitable of using the S is equal to ut plus half at square. So u is 0, S is equal to u is 0 into 3 seconds plus half into a is don't know, it is v minus u divided by t into t square. You just cancel t with t square. S is equal to 0 plus 1 by 2 into v, it is 21.6 minus u is 0 into it is 3. T square, 1 t will be cancelled, only t is remaining, t is 3 seconds. So now S is equal to 21.6 divided by 2 into 3. S is equal to, so 2 10 20 2 8 16 into 3. S is equal to 32.4 meter is the distance travelled by this body under this circumstance. So, before going to find the solution of the problem, so I request scan the problem properly. If you scan the problem, definitely you will understand what is given, what is required to find. If you know this extent of, if you have this extent of idea, 50% of the problem will be over. Rest of the thing is just to find the what required, what is expected from the given problem. Next, move on to the next problem. Go through the next problem. A bullet of mass 10 gram enters a wooden plank with a velocity of 20 meter per second and pierces through 10 centimeter. Find the resistance offered. So, a bullet whose mass is 10 gram is fired from rifle or gun, anything etc. Then it moves with a velocity of 20 meter per second. On its way there is some wooden plank. So, when the bullet moves with such an extent of velocity, it can penetrate the wooden plank. So, during the time of its penetration, definitely according to Newton's third law of motion, that wooden plank shows an opposition. So, that opposition we specifically referred here it as a resistance during the time of its penetration. So, what is the opposition shown by the wooden plank? So, this is the problem. There is a bullet whose mass is 10 gram. When it is fired, it moves with a velocity of 20 meter per second and penetrates a wooden plank through a distance of 10 centimeters. So, during the time of its penetration, what will be the resistance offered by the wooden plank? So, what is the given data? You have to collect mass of the bullet. Okay, it is 10 kg. 10 kg or 10 gram? It is 10 gram. Mass of the bullet is 10 gram. Then it enters a wooden plank with a velocity of 20 meter per second, means its initial velocity is 0, final velocity is 20 meter per second. So, and pierces through 10 centimeters, I mean it penetrates through a distance, you can treat it as a distance. S is equal to 10 centimeter, S is equal to 10 centimeter. Find the resistance offered. So, resistance means opposing force. So, you just require to find what is the opposition held for the body. This is the concept. So, what is the opposition held for the body means F is equal to ma is the usual formula. So, according to Newton's second law, F is equal to m into A. So, F is unknown, mass is given, A is unknown. To have A, so you can write the basic definition V minus U divided by T. V is known, U is known, T is unknown. So, to find T, what is the formula you have to use? You just find V is equal to U plus AT, not useful because A is not given. So, S is given. So, try for V square is equal to U square plus 2AS. So, directly you can calculate the acceleration by using that formula because V is given, U is known, S is also given. Therefore, so V is 20 square which is equal to 0 square plus 2 into A into S is 10. First you just think whether all these are in SI system or not. 20 meter per second, S is in 10 centimeter. Centi means 10 power minus 2. So, for 10 centimeter it is 10 into 10 power minus 2 meter. So, it is 10 into 10 power minus 2 meter. It is simply 10 power minus 1 meter is the distance travelled by the bullet through the wooden plank. Now, simplify it. It is in meter per second, it is in meter, it is in gram. So, mass is in gram means 1 gram is 10 power minus 3 kg. this is 10 power minus 2 kg is the mass. Now 20 square, this is, so it is 2a into 10 power minus 1. This is 400 is equal to 2a divided by 10, it is, cross multiply it, 400 into 10 is equal to 2a, a is equal to 400 into 10 divided by 2. 2 ones are 2 5s are, a is equal to 2000 meter per second square is the acceleration. Now, since we are getting directly the value of a, no need of writing a is equal to v minus u divided by t. So, it is f is equal to m into a, m is 10 power minus 2, a is 2 into 10 power 3 it is. Is it clear? So, instead of writing 2000, I just write 2 into 1000. It is 2 into, once again bases are same, power must be added, minus 2 plus 3 it is plus 1, f is equal to 20 Newton is the resistance offered by the wooden block when a bullet of mass 10 gram moves with a velocity of 20 meter per second and pierces through a distance of 10 centimeter. F is equal to 20 Newton is the answer. In this way, you have to calculate the resistance offered by the bullet. Now, let us move on to the next problem. So, what is the next problem is, a bullet of mass 10 gram is fired with a velocity of 960 meter per second from a rifle of mass 3 kg. Find the recoil velocity of a rifle. Here, so two items we are going to make use. One is the bullet, another one is the rifle. In the previous problem, only there is a information regarding the bullet is given. Here, the bullet and rifle information both are given. So, you have to make the two items. One is the information regarding the bullet is, so you have to cover under the title of B, and another one is you have to cover under the title of R. B stands for bullet and R stands for rifle. So, its mass you call it as m1 and its mass you call it as m2. Its initial velocity as u1 and its initial velocity as u2. Its final velocity as v1 and its final velocity as v2. Now, what is given? You just go through the problem. A bullet whose mass is 10 gram, m1 is equal to 10 gram. 10 gram is fired with a velocity of 960 meter per second, that is the velocity of a bullet. So, its initial velocity is 0, both initial velocity of bullet and rifle are 0, its final velocity is 960 meter per second. 960 meter per second from a rifle whose mass is 3 kg, m2 it is 3 kg. Now, what it is required? Find the recoil velocity of a rifle. While explaining the law of conservation of moment, so I will give this example. When bullet is loaded in a rifle and fired, bullet moves with a tremendous velocity, but the rifle moves in the opposite direction with a minimum velocity. If you calculate the momentum of the bullet, because of its velocity, it seems to be more. At the same time, the momentum of the rifle is also same because its mass is much more when compared to the mass of the bullet. In case of the bullet, velocity is more, mass is less. In case of the rifle, mass is more, so its velocity is less. The moving the rifle after firing a bullet in the opposite direction, it will be referred here as a recoil velocity of a rifle. So, you are going to find the final velocity and will be treated as a recoil velocity. There is a bullet whose mass is 10 gram and it is stored in a rifle of mass 3 kg and fired. when it fires, it moves with a tremendous velocity of 960 meter per second. Now, with what velocity the rifle moves in the opposite direction, that is called as a recoil velocity of a rifle. So, you can solve this problem by using the law of conservation of momentum. According to law of conservation of momentum, you can write m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2, m1 u1 plus m2 u2. So, I mean total initial momentum before collision must be equal to total final momentum after collision is the law of conservation of momentum. So, here you observe here each and every physical quantity is there in the same system of unit or not. So gram is there, meter per second is there, kg is there. So, you just see these two are in terms of the SI, but it is not. Again you have to convert it in terms of the SI system. 10 is there. For 1 gram there is 10 power minus 3 kg, because 1 kg is equal to 1000 gram. Now, it is 10 power minus 2 kg is the mass of the bullet. So, m1 is 10 power minus 2, u1 is 0 plus m2 is 3 kg, u2 is also 0. Coming to the right hand side, m1 is 10 power minus 2 kg, v1 it is 960 plus m2 is 3 kg, v2 it is required to find. So, 0 into anything is 0, 0 into anything is 0. So, in the right hand side it is 10 power minus 2 into 960, I will rewrite it as 96 into 10 plus 3 times v2. So, 0 plus 0 is 0, it is when bases are same, power must be added, it becomes 10 power minus 1 into 96 plus 3 times v2. So, 0 is equal to 96 divided by 10 plus 3 times v2. Now, 3 times v2, so when we transfer this entire quantity to the left hand side, it becomes minus of 96 by 10. So, cross multiply it, v2 is equal to minus 96 by 10 into 3. So, 3 3s are 3 2s are. So, v2 is equal to minus of 2 5s are 2 16s are. This is minus minus 3.2 meter per second is the recoil velocity of a rifle. Please note that the negative sign indicates that rifle moves in the direction opposite to the direction of the bullet. So, this is how calculate the recoil velocity of a given rifle. So, by using the law of conservation of momentum. So, from the examination point of view, so if there is a question on state and verify law of conservation of momentum, this problem may not be given. If that question is not given, definitely one problem is usually given on the law of conservation of momentum. Situation may be different. So, solving the problem using law of conservation of momentum is by this method seems to be very easy. Try for it. So, move on to the next problem. A body of mass, 16th one it is, a body of mass 2 kg moving with a uniform velocity of 40 meter per second collide with another body at rest. After collision, the two bodies move together with a uniform velocity of 10 meter per second. So, what is the mass of the second body? So, go through the problem. There is a body whose mass is 2 kg moving with a uniform velocity. So, here mass of the body is 2 kg. So, moving with a uniform velocity of 40 meter per second, you call it as here two bodies, body 1 and body 2. So, mass of this one is m1 and mass of this is m2. Initial velocity of this one is u1, initial velocity of this is u2, final velocity of this one is v1 and final velocity of the second body is v2. A body whose mass is 2 kg moving with a uniform velocity of 40 meter per second means initial velocity of the first body is 40 meter per second. Collide with another body which is at rest means, so its initial velocity is 0, initial velocity of the second body is 0. After collision, the two bodies move together with a uniform velocity of 10 meter per second. So, understand the given problem. After collision of these two bodies, one is at rest, another moves with 40 meter per second, both together moves with a uniform velocity. So, two bodies move together with a uniform velocity means the final velocity of the first body is equal to final velocity of the second body, which is equal to 10 meter per second here. So, both they move with a common velocity 10 meter per second. What is the mass of the second body? It is required to find what is the mass of the second body. So, in this way you have to understand the problem. So, I just explain the problem once again. There is a body whose mass is 2 kg. Initially, it moves with a velocity of 40 meter per second. It undergo collision with somebody which is initially at rest. After collision, both the bodies together moves with a common velocity of 10 meter per second. So, if it is so, what is the mass of the second body? It is required to find. So, once again, it is a problem belongs to law of conservation of momentum. So, you can say law of conservation of momentum as m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. I mean, so total initial momentum before collision must be equal to total final momentum after collision. So, once again check whether all the given physical quantities are coming under same system of unit or not. Kg, meter per second, no problem. M1 is 2, so U1 is 40, M2 is unknown, U2 is 0, M1 is 2 kg, V1 is 10 meter per second, M2 is unknown, V2 is also 10 meter per second. So, 2 into 40 is 80 plus 0 into anything is 0. So, which is 2 into 10 is 20, it is 10 m2. Now, 80 plus 0 it is 80. When 20 come to the opposite side, it becomes minus 20. So, remaining on the right hand side is 10 m2. 80 minus 20 it is 60, which is equal to 10 m2. Therefore, m2 is equal to 60 by 10. So, that is m2 is equal to 6 kg. So, this is the mass of the second body. So, this is mass of the second body. This is how the required data has been calculated using law of conservation of the momentum. So, before going to start the problem, once again I request, please try to understand the problem, then rest of the job is very easy. So, move on to the next problem. A body of mass 20 kg moving with a velocity of 54 km per hour is brought to rest in 0.03 seconds. There is a body whose mass is 20 kg, moving with a velocity of 54 kmph, I think it is its initial velocity, 54 kilometer per hour. So, is brought to rest, its brought to rest means its final velocity is 0. So, in 0.03 seconds, t is equal to 0.03 seconds. Now, the thing is, find the impulse or impulsive force. So, you just recall the definition of impulse of a force. Impulsive force can be defined as a product of the large amount of force acting on a body within a short interval of time. So, this is one of the definition. Impulsive force can also be given as change in momentum of the body. Impulsive force is equal to F into T is the one of the definition. Impulsive force is equal to mv minus mu. So, final momentum minus initial momentum, that is change in momentum, also gives the impulse of a force with respect to given data. So, which formula is suitable, you have to think. So, impulse is wanted, mass is given, force is not given, time is given. So, F is equal to m into a, m is given, u is a is not given, u is there, v is there, t is there, therefore, finding the a is not at all a problem. So, before that check whether all the given physical quantities are coming under the single system of unit kg, kmph, second, convert it into meter per second. Once again following the same convention, kilo means 10 power 3, so per it is per hour means 60 into 60. Now, it is meter per second. This is 54 into 10 power 3, it is 6 into 10, 6 into 10. 10 gets cancels with the 10 cube, 6 9s are, 3 3s are, 3 2s are, it is 1.5 into 10. So, it is 15 meter per second is the initial velocity. Now, what we means impulse? Impulse is equal to force into t. Force is m into a into t. That is m into a means v minus u divided by t into t. So, t, these two t gets cancels, m is how much? So, mass it is 20, v it is, how much is v? V is 0 minus u is 15. So, it is minus 300 Newton second is the impulsive force. So, the impulsive force act on a body is 300 Newton second. Force is Newton, time is there in terms of second. This is how impulse of a force can be calculated. So, move on to the next problem. Here also this is also a problem belongs to impulse of a body. I think it is 17th, a body of mass 20 kg, 17th is over, 18th. The velocity of the body of mass 10 kg changes from 10 to 20 meter per second. So, calculate the impulse of the body. So, here also the same type of the problem it is. Problem belong to impulsive force. There is a body whose mass is 10 kg, m is equal to 10 kg. So, changes its velocity from 10 meter per second to 20 meter per second. So, here, so initial velocity it is 10 meter per second. So, final velocity it is 20 meter per second. Time is not given, I think it may be a mistake. The velocity of a body of mass 10 kg changes from 10 to 20 meter per second. So, calculate the impulse of the body. So, I mean by using a change in momentum you can calculate, okay, no problem with the problem. So, again impulsive force can be given as change in momentum. Change in momentum means final momentum minus initial momentum. So, it is simply m into v minus u. So, it is m is how much? 10 kg, v is 20, u is 10. So, 10 into 10, which is 100 Newton second is the impulsive force. So, if time is given, you can calculate it by as the product of impulse is equal to force into time. So, since time is not given, you can make use of the one more definition, that is impulsive force is equal to change in momentum. Now, move on to the next problem. Problem. A force of 40 Newton acts at a point making an angle 30 degree with the horizontal. Find the vertical and horizontal component. So, it is a problem belongs to basics of statistics. A force of 40 Newton acts at a point making an angle theta is equal to 30 degree with the horizontal. We know that the angle made by a vector or a force with its horizontal component will be abbreviated as theta. Here theta it is equal to 30 degree. Find the vertical and horizontal component. What is its vertical component? At the same time, what is its horizontal component? Once again, so what problems we solve under this session are the problems which are given in the previous examinations. So, if you are able to calculate these problems comfortably, definitely you will get a same type of the problem in the forthcoming examination also. So, try for it. So, here what it is required, what is its vertical component and what is its horizontal component. We know that horizontal component H is equal to F cos theta. So, that is H is equal to F is 40 Newton into cos of 30 degree. H is equal to 40 into, we know that cos 30 is root 3 by 2. So, H is equal to 20 root 3 Newton is the horizontal component of a force 40 Newton, which makes an angle 30 degree with the horizontal component. Similarly, so what is the vertical component of the same force is V is equal to F sin theta. That is V is equal to F is 40 into sin of theta is 30. V is equal to 40 into, we know that sin 30 is 1 by 2, V is equal to 20 Newton is the vertical component of the force. This is how horizontal and vertical component of a forces are calculated. Now, move on to the next problem. A force is inclined at 30 degree to the horizontal, means again theta is equal to 30 degree. If the horizontal component is 30 kg, so H is given, H is equal to 30 kg, then what is required to find? Find its vertical component. This is the given data. We know that to calculate the vertical component, we use the formula V is equal to F sin theta. So, theta is known, but F is not known, but horizontal component is known. By using the given horizontal component, try to find the original force. We know that H is equal to F sin theta, that is F is equal to H by sin theta. So, F is equal to H, it is 30 kg divided by it is sin 30. This is 30, sin 30 we know that 1 by 2. The denominator of the denominator goes to the numerator, 30 into 2, original force is 60 kg because horizontal component is given in terms of kg. Now, F is calculated. So, required vertical component is 60 into sin 30. that is V is equal to 60 into sin 30 is 1 by 2, V is equal to 30 kg is the horizontal component of the force which is inclined at 30 degree and its magnitude is 60 kg. So, this is how calculate this force. Now, move on to the next problem. This is also problem belongs to horizontal and vertical components. You see, a force of 30 Newton acts on a body in the north direction. Find its component towards east. Find its component towards east. So, you know the different direction. So, this is north, this is south, this is east and this is west. What it is given is a force of 30 Newton acts on a body in the north direction. So, here it is F is equal to 30 Newton towards north. Find its component towards east. So, I mean, so it is nothing but a horizontal component is given, find its vertical component, that is all. What is its vertical component? Between the horizontal and vertical component, in this case theta is equal to 90 degree. Definitely in this case theta is equal to 90 degree. So, this is horizontal component, this is vertical component. So, here it is in other way it is required to find what is the horizontal component of a force. We know that H is equal to F cos theta. We do not know how much is F, let it be. Cos of theta is 90 degree. We know that cos 90 is 0, 0 into anything is 0. So, if a force of 30 Newton acts in the north direction, definitely its component towards east is 0 Newton. So, this is also a marks awarded for the 5 question. That is why try to understand the problem comfortably. So, moving on to the next problem. Forces 7 kg weight, 15 kg weight and 13 kg weight acting on a particle which are in equilibrium. Find the angle between the first two forces. Find the angle between the first two forces. So, 3 forces are given, one is 7 kg weight, 15 kg weight and 13 kg weight acting on a particle. All the forces are in equilibrium. Find the angle between the first two forces means what is the angle of inclination of the two forces, I mean 7 kg weight and 15 kg weight. So, the given data you will be collected as P is the first force, Q is the second force and R is the third force. Angle between the first two forces is nothing but a theta. So, first force is 7 kg weight and the second force is 15 kg weight and the third force is 13 kg weight. So, if the 3 forces are given, you can recall the magnitude of the resultant when 2 forces acting at a body simultaneously whose angle of inclination is theta, that is R square is equal to P square plus Q square plus 2 PQ cos theta is the equation used to calculate the resultant of the resultant of the 2 forces which are inclined at an angle of theta. Here we are required to find the theta, is it not? R square means it is 13 square. So, P square Q square plus 2 into P into Q cos theta. 13 square is 169 which is equal to 7 square is 49 plus 15 square is 225 plus, so in 210 cos theta. 169 it becomes minus 49 minus 225. So, 210 cos of an angle. So, here it is 120 minus 225, which is equal to 210 cos theta. It is minus 105, which is 210 cos theta. Therefore, cos theta is equal to minus 105 by 210. So, 1s are 2s are. Cos theta is equal to minus 1 by 2. Theta is equal to cos inverse of minus 1 by 2. So, cos is negative in second quadrant, standard value is 60 in second quadrant, maximum angle is 180 degree, 180 minus 60, it is 120 degree is the angle of inclination between these three forces which are acting on a body and are in equilibrium. This is how angle of inclination can be calculated. So, move on to the next problem. The horizontal and vertical components of the force acting at a point are 7 Newton and 25 Newton respectively. Find the magnitude and direction of the resultant. So, one is the horizontal, another is the vertical. You can take first one as P, which is horizontal force, which is equal to 7 Newton. Another force is Q, which is vertical component, which is 25 Newton. The angle of inclination between the horizontal and vertical, here it is theta is equal to 90 degree. What is the magnitude of the resultant and direction of the resultant, right? So, once again R is equal to P square plus Q square between the two perpendicular forces, because theta is equal to 90 degree means, so cos 90 is equal to 0, remaining is P square plus Q square. R square, R is equal to P square, it is 7 square plus it is 25 square. R is equal to, it is 49, I think it is 625. So, R is equal to 674. So, it is Newton is the magnitude of the resultant. So, what is the direction of the resultant? Tan alpha is equal to Q sin theta divided by P plus Q cos theta. Here tan alpha is equal to, theta is equal to 90 means sin 90 is 1, it is Q divided by P. Alpha is equal to tan inverse of Q is 25, P is 7. So, alpha is equal to tan inverse of .5 something. So, alpha is equal to something. So, move on to the next problem. The resultant of two equal forces acting at right angle to each other is 1414 Newton. So, find the magnitude of each force, the resultant of the two equal forces. Two equal forces means here P is equal to Q. So, which are right angle to each other means theta is equal to 90 degree. E is 1414. So, that is resultant is 1414 Newton. Then find the magnitude of each force. So, I mean P is equal to how much and Q is equal to how much. Once again this is the problem belongs to resultant of the two mutually perpendicular forces. We are deriving the formula as R is equal to square root of P square plus Q square. So, that is R is 1414 Newton. So, I will replace Q by P also, Q by P itself, because Q is equal to P. So, P square plus Q P square, it is 2 times P square. So, 1414 which is equal to, when you write the P outside the square root, so it becomes only P. So, P square if it comes outside the square root, it becomes P. Therefore, P is equal to 1414 divided by root 2 Newton. Since P is equal to Q, this implies Q is also equal to 1414 by root 2 Newton. So, this is how the two equal forces which are inclined perpendicular to each other, whose resultant is 1414 Newton. So, move on to the next problem. If two forces equal and the resultant is also equal in magnitude to either of them, at what angle it will be inclined? That is the question. So, here two forces, two forces are equal and the resultant is also equal means P is equal to Q is equal to R. At what angle they are inclined? Theta is equal to how much? Once again recall, R square is equal to P square plus Q square plus 2 PQ cos theta. So, all these three forces are equal, therefore, you have to write any one of the abbreviation. I will replace everything by P. P square is equal to P square plus P square plus 2 into P into cos theta, because two equal forces and the resultant is also equal to any one of these two. Now, so P square, this P square comes this side minus this also comes this side minus the remaining thing on the right hand side is 2 PQ, 2 P into P, it is P square. So, it is 2 P square cos theta. So, minus P square gets cancels with the plus P square, it is minus P square divided by 2 P square which is equal to cos theta. P square gets cancels, therefore, cos theta is equal to minus 1 by 2, it gives theta is equal to 120 degree, theta equal to 120 degree. So, we stop our discussion at this stage. If time permits, so I will solve few more problems so on this concept. So, thank you one and all.